Hello, this is Yan Yan from Team Visualize, presenting file-based physician dashboard for managing opioid prescriptions. We are a team of 6. Valad is our project manager. Dong is a back-end developer. John, Lillian, and Jeremy are front-end developers. Me, Yan Yan, is a data analyst. Mortality rate due to opioid overdose has been increasing over the last 10 years. Clinicians are faced with the challenge of preventing possible opioid overdose by prescription monitoring. In 2016, CDC published guidelines for opioid prescription. Applications implementing these guidelines are limited. A smart-on-file app within EHR is desirable. Our project ends up developing such a file app, displaying patient prescription history, focusing on risk assessment of possible opioid overdose. Left is our original prototype, right is the current one. Major changes are, now we focus on displaying risk factors, making prescription history a primary section with changeable time range. These changes are made upon mental feedbacks.
Hi, this is Don Ward. I'm going to talk about what we implemented in the backend. We set up the basic API in accordance with UI expectations, integrated with the Harvard and the UHNCA FHIR servers, and we merged federated data comprised of opioid prescriptions and risk factors. The application prototype is comprised of two main pieces. The first is a user interface built using React.js for responsive component-based user interfaces. The second is a REST API built using Java on Spring Boot. The application, when launched using a smart-on-fire-enabled EHR, communicates through the REST API, retrieves data from FHIR-enabled servers, and builds a dashboard used to help make a clinical decision. The dashboard federates data from multiple sources. This diagram illustrates the data aggregation in a hypothetical encounter. In step 1, a patient visits a hospital and receives medication. In step 2, a patient visits a second hospital and receives more medication. In step 3, when the patient visits a physician using the PPOD dashboard, the physician will receive an aggregate picture of the patient opioid usage and risk factors. The back-end REST web application follows a classic Spring Framework architecture. The web layer in our example uses Jackson to serialize data transfer objects to and from JSON. The service layer coordinates web layer interactions with the business logic, domain model, and client FHIR calls. And the repository layer uses the Java persistence architecture for data persistence.
Hello, this is John Fisher. I'm going to talk about continuous integration and deployment. First, the student pushes to GitHub. Jenkins then pulls from GitHub and pushes to Docker registry. Rancher then pulls from Docker registry and pushes to Docker Swarm. This content is delivered via Apache. From the UI implementation side, the app is launched as a smart-on-fire application, and it closely matches wireframe prototypes developed early in the semester. This includes a section on risk factors, opioid usage chart, prescription history, and time range filter. The app was developed with the React.js library. Mentor feedback generated several points for improvement. This includes the fact that risk factors should be displayed prominently, dosages should be continuous, prescription history should be a primary section, the time range for the opioid usage graph should be adjustable, and tooltips should be usable to provide physicians with drill-down information. As you can see, our final product reflects these requirements. We'll now go through a demo.
My name is Vladimir, and I will be giving you a quick demo of our completed application. It is a smart-on-fire app, and thus is launched in the context of an EMR or EHR. For demo purposes, we're using Smart Health IT's EHR simulator to illustrate the app capabilities. We're starting on the main Smart App Launcher page provided by Smart Health IT. Here we can specify that we'd like to simulate the app within the EMR and EHR, and that we're using the FHIR version 3. At the bottom of the configuration page is where we specify the launch page for our smart app and launch the simulator. Similar to the real-world scenario, a physician would have already been logged into her EMR and would need to pull up the records for the patient who is in front of her. In our case, we can try with our test patient, Emerson. Once patient has been selected and our app loads within the context of the EHR and the patient, Our app pulls information from two different FHIR servers for the same patient and effectively merges the information into one cohesive dashboard. We're using Smart Health IT FHIR server and UHNCA FHIR server. As described in the research section of this video, the top row of risk factor sections have been identified to be important considerations for physicians when deciding on whether to prescribe opioid medications to the patient or not. Primarily, physicians are looking for any red flags that could hint at any addiction tendencies. The first three risk factors are self-explanatory. Whether the patient smokes and what frequency, do they drink alcohol, has there been any history of substance abuse, overdose. Those are clear indicators. The last section tells you about signals for any drug combination issues. So for example, if an opioid medication is taken together with a sedative or a benzodiazepine drug, this could cause severe side effects. Just below the risk factors, we display a history of prescriptions for the patient. As you might notice, the prescription history shows you the medications with different dosages and strengths. Some are in milligrams, some could be in milligrams per hour, and so on and so forth. When evaluating a viability of prescribing opiates to a patient, it's important to follow CDC's guidelines, which state that an addiction risk for a patient dramatically increases when the total morphine equivalent dosage of the opioids exceeds 50 morphine equivalents, and extremely dangerous when it exceeds 90 morphine milligram equivalents per day. So today, without a tool like ours, physicians have to manually calculate patients' current daily MME intake by converting all current patients' medications and their dosages into morphine equivalents. Our app adds a significant improvement to physicians' decision-making process by auto-converting all opioid medications to MMEs on the fly. So here you could see a total daily opioid usage of the patient in MMEs. And as you could see that in the recent days, the patient's dosage exceeded the 50 band, MME band that CDC warns you about. Here on the top, in the middle section, you can view the prescriptions for different days, different time spans. That was something that our external mentors were really excited about. And here in the future, there are capabilities for integration with a PDMP, which is a medical report that shows all of the medical visits that the patient had and the urine test that can tell them whether the patient is on any opioids right now that the physicians don't know about. And that is our patient opioid dashboard app. Thank you.
My name is Jeremy, and I'm going to take a minute to revisit our project's goals to define outcome. We succeeded in connecting multiple FHIR services by pulling patient information from both Harvard and UHN. Our application also displays the patient's prescription history, assesses risk, and includes the CDC's guidelines for daily MME intake. Our project uses a variety of unique elements. We have shown interoperability by merging patient data from two separate FHIR services in order to create a more complete view. Also, we've incorporated CDC guidelines by displaying warning bands according to risk thresholds with regards to MME intake. This will aid physicians in making more informed opioid prescriptions. Here you can see the final version of our team's Gantt chart. As you can see, we proceeded through the majority of the development phase and the entirety of the testing phase since our last deliverable. Looking forward, our external mentors at the Regenstrief Institute are planning to showcase our prototype and collect feedback for future improvements. Their plan is to continue development either in-house or with one of next semester's teams. This prototype will be used for a grant to fund their next opioid-related project. On behalf of all of us at Team Visualize, thank you. We are grateful for this opportunity to apply what we learned during this course towards a real-life solution.